area trapped between curves. To find the area between curves, first find the intersection points of the curves. Find the area by one of two methods, and the first of those is as the difference between the areas under the two functions. So let's explain that. So if we have g of x and we have f of x, what we're trying to find here, and we find the points of intersection first, we're trying to find this area. Now let's consider this again. This is the area underneath the higher of the two functions in this range, which is f. We can see it's above g between a and b. So the purple shading is the integral from a to b of f of x dx. The red shading is the area underneath g of x. So we evaluate that with the integral from a to b of g of x dx. Now the green area, which we can see in this diagram, is going to be the purple area take away the red area, giving us the difference of the areas under the two functions. We can also do this as the area under the difference function, because if we have the integral of f of x take away the integral of g of x, that's the same as integrating from a to b f of x minus g of x dx. Note, careful note must be taken of the points where the curves cross to avoid areas cancelling, in the same way as when part of a curve is above the x-axis and a part below, if we're just finding the area under a curve. Consider the diagram below. To work out the blue shaded area by hand, we must consider which function is on top. So, the area would be the integral from a to b of f of x minus g of x, because f of x is above g of x here, plus the integral from b to c of g of x minus f of x, because we note that g of x is above between b and c. If we are doing this on the calculator, no such consideration is needed, as we can make use of the absolute value function, and we just integrate all the way from a to c the modulus of f of x minus g of x dx. Remember, the modulus function will always return a positive, so it doesn't matter which function is on top.